students, welcome back to my YouTube channel. In this video I am going to discuss about motion of a charged particle in a magnetic field. Okay, so this is especially for NEET and JEE students. In this we will discuss about what are the type of problems are going to be asked based on these topics in the NEET and JEE exams. Okay, so what is the force acting on a charged particle when moves in a magnetic field? That force is called as Lorentz force. That is magnetic force. Okay, so a charged particle is moves in a magnetic field, it will experience a force. That force F is equal to Q into V cross B. Okay, that means Q is equal to VB sin theta. Okay, what is theta? Theta is the angle between V and B. That means you can see this. Here the magnetic field is acting like this, and if a charged particle is moves with a velocity V like this. Okay, so it will experience a force. This force direction can be found out by using two rules. One is Fleming's left hand rule. Fleming's left hand rule, and the second one is right hand rule. Right hand rule. Okay, so first we will see how to find out the left hand rule. In the left hand rule, stretch your left hand three fingers, that is thumb, forefinger and the middle finger. The forefinger plays in the direction of magnetic field and the middle finger plays in the direction of velocity, then the thumb will give the force direction. So you see here, I am going to place my forefinger in the direction of magnetic field, the middle finger in the direction of velocity, so the thumb is in the force direction, that is the upward direction. This is the force direction. Okay, so forefinger, magnetic field, middle finger, velocity, and the third one is thumb, force direction. Clear? This is the Fleming's left hand rule. And how you will apply the right hand rule? Place your right hand in the direction of first vector, that is a velocity vector, and curls towards the next vector, that is a B. That means I am placing my right hand like this in the direction of first vector, that is a velocity direction, and curl like this, curl like it, curl into it. So I will get the thumb direction. That thumb direction is the force direction. Clear? Okay, this is the way we can find out the direction of the magnetic force. And we will see one more example. If the magnetic force is to be acting like this, okay, then what is the force acting on a negative charge is moving in this? Okay, if a negative charge is to be moving in this, what is the direction of force? This direction of force is to be based on the positive charge. If it is a negative charge, you have to consider it as a positive charge. Then you find out the force direction. Finally, you take the opposite direction. That is the force acting on the negative charge. Okay. So I am now assume this charge is a positive charge moving in this direction. Okay. So I will place my right hand like this and curl in which direction? Upwards like this. Okay, so this is the direction. If it is a positive charge, the force is to be in this direction, but it is a negative charge, so I will take the final direction is upwards. Okay, this is the force direction. Clear? Okay, then if this theta varies, the force will be acting on the charged particle changes the path of the charged particle. That means we will take the case 1. In the case 1, theta is equal to 0. That means B and V are in the same direction. That means you see this, the magnetic field and the velocity. This charged particle is moving in the same direction. What about the force? F is equal to Q into Vp. Sine here theta is equal to 0. So this force is to be 0. So there is no force acting on it. No force. And what about the path of the charged particle? There is no changes in the path of the charged particle. Charged particle moves in the same path. Okay. No change in the path. Okay. Then case 2. If theta is equal to 90 degree, that means charged particle enters into the magnetic field perpendicular. That means you see this case here, the charged particle magnetic field is to be acting like this, and the charged particle is moves like this in this direction. What about the force? So you see this here, the force F is equal to, that is QVB sine 90. So that is equal to, F is equal to QVB is the force acting on it. Okay. So we will see the direction of force. You see this, place my right hand in the direction of velocity and curl into it. So I will get the direction is like this. So I will get the force direction is like this. So here the path of the charged particle is to be changes and it will move like a circular path. Okay. So in this circular path I need to find out the radius of the circular path. Like this is a magnetic field. This is the case is to be. This is the what case? Case 2. And theta is equal to 90 degree. Okay. So what is the radius of the circular path we have to see. Okay. For this you can see that if a charged particle is moves in a magnetic field, it will experience a force that is QVB, that is if it is perpendicular. So anything is moves in a circular path. This path is to be what? Circular path. Circular path. Any charged particles moves in a circular path, it needed a centripetal force. Here, this magnetic force is to be changes to the centripetal force. This is the magnetic force. This force is to be changes to the centripetal force. Okay. So magnetic force is equal to centripetal force. That means QVB is equal to mv square divided by r. Okay. I'm not going to do the derivation and directly substituting the formula that R is equal to, you can get the R is equal to mv divided by qb. Directly you can find out from this. This is the radius of the circular path. Then you can find out the frequency. How you will find out V is equal to omega R. Okay, from this you can find out the frequency, that is to be, you can get it as qb divided by 2 pi m. Okay, what is the m? M is the mass of the charged particle, moves in a magnetic field. B is the magnetic field and Q is the charge of the particle. Okay, what is meant by frequency? Number of revolution per second. Then what is the time period? Time period is equal to 1 by mu. So T is equal to what you get? 2 pi m divided by QB. Clear? 2 pi m by QB. Clear? This is the formula for the time period. This is the formula for the radius. Here you see that the radius is to be directly proportional to velocity. That means velocity increases, radius of the path will be increases. Clear? Okay. And this is the thing. Okay. Next, this is the formulas you have to remember in this second case. These are all the formulas you have to remember. This time period formula, radius formula, this frequency formula, this concept, everything you have to keep in your mind. Okay. This is the second case. Next we will see the third case. In the third case, case 3. In the case 3, theta is equal to theta itself. Theta is equal to some degree. That means magnetic field and velocity have some angle. That means you see this. If the magnetic field is to be acting like this, velocity, the charge particle is moves, it will make a velocity like this. It's making an angle. Okay. So this velocity have two components. One is along like this, that is a perpendicular component, and another is to be like this. This is a parallel component. This parallel component try to make the charge moves like this, and the perpendicular component try to make the charges move in a circular path. Okay. So the combined effect of the circular motion and the linear motion. So you will get the helical path. You will get like this. Okay, so the charge particle is moves in a helical path. Now we will see the radius of the helix you want to find out. Okay, what is meant by radius formula? Radius is equal to mv divided by qb, the same formula, but there is a change here. This is a perpendicular component because the perpendicular component make the charges to move in a circular path. So the radius is to be this formula. What about the time period? Time period have no changes, that is 2 pi m by qb. What is meant by time period? Time taken to complete one rotation. Frequency of formula also there is no change. Here we have to see a time, that is pitch. What is meant by pitch? It is a linear distance moved by the charge particle when one complete rotation. In one complete rotation, how much is the linear distance moves? Okay. That pitch we can find out this formula, that is V parallel into the time period. V parallel into the time period formula is this, that is 2 pi m divided by qb, that is the pitch formula. Okay, this is the thing. So these formulas all you have to remember it. What is the pitch formula, what is the time period formula, what is the radius, this everything you have to keep in remember it. Okay, these are all the formulas you have to remember and the concept about this motion of a charge particle in a magnetic field. Okay. Now we will see what are the type of problems they are going to be asked in NEET and JEE. Okay. First type 1. So in the type 1, if a charge particle is moved in a magnetic field, what is the change in the velocity of the charge particle? That means you see this, the magnetic field is to be acting like this, B, and the charge particle is like this, moves like this. What is the change in the magnitude of velocity? It may increase, decrease, or unchanged, or increase or decrease. What is the answer for this question? Normally, for a general thinking, if you think that there is a force acting, that is what about that force? F is equal to Q into V cross B. So, normally if you think that if there is a force is there, so that force will be changes the velocity. So, our option is velocity increases or decreases like that. Don't put like that. Here you see this. What is the direction of this force? This force is always perpendicular to the velocity. So here the angle between force and velocity is to be 90. Okay, you see this. What is the direction? Direction of force is always perpendicular to the plane containing V and B because it is a cross product. Okay, so here the angle between velocity and force is to be what? It is to be 90 degree. Okay, so you can get that. What about the work done by this force? Work done is equal to what? F was cos theta. Here you will get what? The displacement and velocity are in the same direction. You will get here the theta is equal to what? 90 degree. So work done is equal to what you get? 0. So that means what? This magnetic force is to be not doing any work on this charge particle. That means what? This magnetic force cannot change the magnitude of the velocity. It will only change the direction of the velocity. It will only change the path. So magnitude of velocity is constant. of velocity is constant. Okay, so when a charged particle is moved in a magnetic field, the magnitude of velocity is constant, but the direction can be possible to change by using this magnetic force. Is a type 2. In a type 2, if the magnetic field is acting in north direction, that is, if a earth magnetic field is acting towards the north direction, if a charged particle, that is a proton, if a proton is moves in the along the same direction, what is the force? Here you see that the charged particle and the magnetic field are to be in the same direction, so the force is to be 0. Clear? Okay. And in this type itself, you can see this. If a earth magnetic field is acting towards the north direction, if a charged particle is moves upwards, okay, if a charged particle is moves upwards, that means you see this, if a charged particle E plus is moves upward, this is the velocity direction. What is the direction of the force? The direction of the force can be found out by using Fleming's left hand rule or to be right hand rule. Here I am using the Fleming's left hand rule. So here the magnetic field is to be acting in which direction? This is the magnetic field direction. So this is the velocity direction. Velocity is upward. So I will place my this finger, forefinger in the direction of magnetic field, and the velocity is in this direction. Okay. So I will get what is the direction of this proton. Proton is moved towards the west direction, towards the west. Okay. So we can get this west, this direction, west direction. Okay. So directions we can take like this: north, south, east, west. Okay. This is the type 2 problem, and next type 3 we will discuss. In the type 3, if the same type, that is, if the magnetic field is acting towards the north, if an electron is moves along the same direction, what about the force acting on? If an electron is moves along the same direction also, the force is to be 0, because here you see that if a charged particle is moves along the direction of magnetic field, net force is to be 0. Okay. Then in this type itself, next you see that if a magnetic field is acting in this north direction, if an electron is moves in which direction? Towards east. This is the electron moves towards the east. What about the force acting on it? Thus force can be found out by using Fleming's left hand rule. Please remember, this is a negative charge. Okay. So first I am consider this is a positive charge, and finding the direction, finally I will change the direction. Okay. So I place my this finger, that is the forefinger, in the direction of magnetic field, and this finger in the direction of velocity. Okay. So I will get the upwards if it is a positive charge, but it is a negative charge, so the direction is downward. Okay. So force acting downwards. Downwards. Okay. This is this type, and another type 4. Okay. There is a magnetic field is to be there. In this magnetic field, a charged particle is at rest. If a charged particle is at rest, what about the force? That means velocity is equal to 0. If velocity is equal to 0, F is equal to 0, because F is equal to Q V P sin theta. V is equal to 0, F is equal to 0. So, if a charged particle is at rest in a magnetic field, it will not experience a force, because the rest charge will not produce a magnetic field, so it will not interact with the external magnetic field. Okay. Then we will see the type 5. We will see the type 5. I am going to write here type 5. Type 5. Okay. There is a magnetic field is to be acting in this direction. There is a neutron is to be moved. If a neutron will be moved like this. Okay. If a neutron is moved in this direction, what about the force acting on this neutron? What about the charge of the neutron? The charge is to be here 0. There is no force acting on it. Okay, so this case we can get the answer. So no force. Okay.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like